Our plant is the biggest in the Western Hemisphere. This hot strip mill is the biggest, most productive facility of its kind in the world.
In 1 year, this mill puts out enough steel strip to circle the Earth 15 times. In 1 day, this same mill gulps up more water than the average household would use in over 300 years. In 1 week, the furnaces cook up enough liquid steel to manufacture over 100,000 cars. Welcome to Garyworks in Gary, Indiana. This hotspot is among the world's leaders at spewing out metal for making everything from bridges to fridges to cars.
A car is about 1,200 pounds of steel, so you can talk about 40 to 45 cars out of each one of those slabs.
Garyworks sits here on the shores of Lake Michigan, a technologically enhanced iron giant, a leader in steel production.
The steel products that we're making for automobiles today, 75% of those steel grades that we make did not exist just 10 years ago. So it's tremendous, the amount of technology, the advancements we've made in manufacturing and in the products we make. We're going to lighter, stronger steels so that we make more fuel-efficient automobiles and it's environmentally more friendly.
At 10.5 square miles, this monster steel plant could hold 50 Disneyland theme parks within its walls. At that size, it's basically a fully functional city.
We have our own hospital here. We have our own police department. We have 2 fire departments. We have our own utilities. So it is actually a small community.
There are about 14,000 workers at the mill. But the thing that really gets this community cooking comes from the earth.
Quality starts with those raw materials that Mother Nature made for us.
Several times a week, giant boats arrive at the Gary Slip, loaded with 50,000 tons of iron ore. At 1,000 feet long and 105 feet wide, this boat is big enough to carry the Eiffel Tower. Once the proper ingredients arrive, it's time to make metal.
We take them, mix them, blend them, crush them, heat them up, and we end up with the steel that you see in the steel furnaces coming out in the slabs.
The first step in the process is coal. The coal is loaded and sealed into these narrow ovens, which have been preheated to 2,000 degrees, roughly the same temperature as lava. Cooked without air, the coal turns into a substance called coke. It's a nearly pure form of carbon, used to fuel humongous furnaces. This blast furnace juts 30 stories into the sky. Outside, it's a jumble of steel pipes and scaffolding. Inside, heat and fire make it a brochure for Satan's vacation spot. Soot and sweat are the main companions for these men of steel.
It can get really hot around here.
Protective clothing only adds to the extreme heat and humidity that must be endured in this less than heavenly environment. A typical blast furnace works 24/7 and produces up to 10,000 tons of hot metal a day. As the mixture containing iron ore, coke, and limestone flows down through the flaming hot furnace, the oxygen is roasted right out of it. The result is this molten iron, the basic ingredient of making steel. Steel making is a blend of chemistry class and cooking. Iron, oxygen, scrap steel, and various alloys are the ingredients. Every detail must be perfect. Every 4 to 5 minutes, a sample shoots into this lab. They check the recipe of each batch to make sure the mix and temperature in this molten soup are exact. If it's premium quality, the furnace is tapped. The 3,000-degree liquid streams into gigantic stew pots. Then the molten liquid goes into long molds. The resulting slabs of steel gel as they travel down this conveyor. Thousands of gallons of water speed the process. At this point, the slabs are sliced into 70,000-pound sections for easy handling. So, how do you handle a 35-ton hunk of steel?
I could carry 157 ton with this machine.
The size of a small garage with 9-foot-high tires, the Crest carrier manhandles its huge loads. Its task is to transport these smoldering slabs to the strip mill.
The slabs we take over to our finishing end. That's where the coils are made.
The 9-inch slabs are reheated to about 2,400 degrees. And on a good day, one pops out of this oven every 10 seconds. The fiery hunk of steel zips along at just over 40 miles per hour, being squeezed between a series of giant rolling pins. Next, gallons of gushing water blow off crust and cool the steel strips down to a mild 1,100 degrees. 500 million gallons of water are pumped out of Lake Michigan for use every day. The average family of 4 would use that same amount of water in just under 5,000 years. And it isn't just water. Those gigantic ovens use up a ton of electricity.
The amount of electricity we use at Garyworks in 1 hour would supply my home for 34 years.
In this case, power generates pressure. In fact, 25,000 pounds of pressure is used by these massive rolling pins to flatten the steel strip. By the time the slab reaches this huge coiling machine, it's thinner than a pie crust. From this point, the coils get finished off and batched up like bakery goods. Some end up as appliances, cans, or cars.
Last month we shipped 4,362 coils out of here.
Gigantic ceiling cranes run back and forth the length of this warehouse. The heavy lift computerized cranes allow the operators to pick up the coils and plop them onto trailers or rail cars for shipping. These ceiling cranes are used throughout Garyworks. In fact, there's more than 50 miles of track. Outside this mile-long scrapyard is evidence that the folks at Garyworks are good environmental neighbors. They recycle just about everything.
So if it doesn't make it out the door to a customer, it's recycled into our melt shops, and we make steel again. We also use a lot of scrap. About 20% of our charges here are scrap. So we're using old automobiles, old appliances to make new steel.
And new steel is the name of the game, starting out as heat and sweat and molten metal, and ending up as buildings, bridges, and cars, all thanks to the steel-spewing giant on the shores of Lake Michigan.